Hello everyone, my name is Nemanja Stojanović, and today I will talk to you about some object detection projects I made to figure out as much as possible about this topic. So in a previous company, they assigned me some tasks related to computer vision and object detection, so I was like, why shouldn't I make my own projects to figure out as much as I can about this? And so let's say, so in this presentation I won't talk much about the technical stuff. Mostly it will be demos and my progress, what did I learn and what did I achieve to resolve these problems that were in this task in a previous company. So as probably all of you know, image is just a bunch of pixels, and each pixel can be represented as mostly in RGB color space, which each color usually has allocated 1 byte. So each pixel can be represented as 3 bytes, 1 byte for red, 1 byte for green, and 1 byte for blue. And when you combine these values, you can represent pretty much all the colors. So on the left image you can see grayscale image, and it has just one channel, so each pixel can be represented as just one value. And you can see these values on the left. Well, you can't, but there is just, there are values here. And the basic of image processing are these convolutions, which means applying these kernels, or as probably you know, filters. These filters are just matrices that you apply to this image. You can see one example down there. It's a 3x3 matrix. It has -1 and 8. And when you apply this filter to the image on the left with usage of this convolution, you can get image that looks like that on the right. So the easiest way to explain these convolutions is to show you the demo. It's very simple actually. There is that kernel on the right, or filter, whatever. It has some values. So you go through image, get an area around each pixel, and multiply all the values with these values from a kernel, and then you generate the next value in the middle. So if there is values there that are 1/9 in all of those pixel positions, that means you will get the area around each pixel and average the value. So basically you are blurring the image. If you make kernel bigger, let's say 5x5, and each value in this kernel is 1/25, that means you are going through image, getting the surrounding pixels, get all those values, sum them, and divide by 25. So you're blurring image even more. So these are like basic representation of what convolutions are and how to use them. You can use it for blurring, sharpening. There are fun to use kernels, like you can make edge detection and so on. So because there are a lot of these, I wanted to get familiar with image processing as much as I can. There is OpenCV library in Python that you can use for all of this. And while I was playing with it, I needed my own project to practice. And there is very simple example you can make by combining some of these kernels of filters. So you can cartoonize your image, make image look like someone has drawn it. So this is first my application I wrote. So what's happening here? You have 3D scene on the left, and what I'm doing here, every time you stop moving your scene, event is initiated, and I get the frame buffer. Frame buffer, you can think of it as just an image that will be drawn to the screen. So once I get it, I convert it to NumPy array. At that point, I can do almost anything with it. And then I apply these filters to get this cartoonized look. And there is small GUI written in PySer. So basically, you can make a colored version or black and white version. And as you can see, there is edge detection. So I found the edges, the gradients on the image, and exaggerate these edges by drawing black lines. So this was like the first fun project to me that I could make with image processing. But main task was to do object detection. So previous step is important because when you do object detection, you want to do as much as possible pre-processing and post-processing. You want to give to your neural network as less data as possible. So at this state, when I try to make first object detection, in my previous company, they'll be doing, they're in automotive industry. And as you probably know, there are a lot of standards because human life can get in danger. So all of this has to work really well because someone can die. You cannot have object detection in vehicles. What if you make a mistake? Someone can die. So I decided to use the simpler object detection algorithms that involve just machine learning, and the hard feature classifier was one of the base algorithms. Its idea is published, I think, in 2000 or 2001. And basically what's happening, there are these featured images. You can think of this as just white and black pixels. In grayscale image, there are never like just white and just black pixels, but you can find this feature on the image. Like here we have vertical line, horizontal line, diagonal line, and so on. So when you think about it, you can use this feature to detect human face. This is oversimplification, but that's actually how does this work. So you have a face of a female here, and you can see that eye can be detected as that there will be a row of black pixels, and below it there will be a row of white pixels. And that's not very good to detect eye, but if you combine it with some other hard features and combine and detect them all at once, you can detect the face. Let's say nose could be like one row of vertical white pixels, because most of the light will hit the top of your nose, and there will be two blackish vertical pixels. So if you combine these hard features of eye, mouth, nose, and so on, you could detect successfully human face. And this works pretty fast, what is really important for our project. And the main issue with this algorithm is that you can, if just this female tilt her head a bit, let's say by some angle, you can realize that these hard features are changed completely. Like there, you don't have on the nose vertical lines, there will be diagonal lines and so on. But I wanted to test it because maybe it could be useful for our project. And so my first example was, it should be simple because I've never done it before. And second, I wanted to make an example in which this rotation won't have impact on my example. So the absolute basic would be to just dot detection, just circles, because if you rotate the circles, you still have circles. And the results look like this. So what's happening here? To make this machine learning training, when you build OpenCV, you have these utility executables, and they are actually hard feature classifier executable, and input to these executables are positives and negatives. Positives are the images you want to detect, and negatives are images that don't contain the positives. So I had to write a small script. When you press any key on your keyboard on a laptop, it will save from a camera feed image that's currently presented and saved it in some directory. So when you collect like 500, like several hundred of these images, that will be enough for positives, and negatives you can download from the internet, just thousands or several thousand of them. At that point you have to manually crop them, so this is very tedious work. I had to go through all of these images of dots, crop all of these dots, and then set it as arguments for these executable files that has to train this hard feature classifier. So once everything is done, this can be easily loaded in your Python application, and you can do something like this. As you can see, this works quite okay. I tried to test it with different angles. There are some issues. You can see it detects the edge of the seat in a train. So it's not perfect, but at that point I figured out, okay, this can work. So I wanted to test it now even more. I needed another example. And another example, I figure out I should use is letter detection, but almost everyone does letter detection. I had to change it a bit, make it my own example. So I used Arduino and 8x8 LED matrix, and every second this LED matrix should present different letter. And I should make 26, obviously, these hard feature classifiers, and I want to see how well can it detect each of these letters. So just ignore the green dots on the face. Those are face landmark detection. That's something I did afterwards, so just ignore it. So as you can see, there are letters down there and there are letters up there. And we get these green dots every time if the confidence level is about 50% that this letter is detected. As you can see, there are a lot of errors. Mainly it can detect the letter. It has some issues, I think, with X and Y and A, but besides, it mainly detects the right letter. But in this example, I figured out, okay, these rotations are really a problem. Once I rotated a bit, it didn't work. And at that point, I figured out, okay, I have to use neural networks. This can be useful in some cases, but there are a lot of issues. And as you probably can figure out, you can do a lot of pre-processing here to make this example work like really nice. If I just convert this image to different color space, I don't know if you're familiar with it. If I convert it to HSV color space, from a third channel that's V, I can get the most intensive pixels. So I will get these white pixels. And with next steps, I can check if these white pixels have surrounded red pixels, and if that's the case, I can just extract these values and discard 95% of the image. At that point, this detection will work much faster, and I could cheat. I mean, I could detect for instance, if the P is detected and if the O is detected, I can check if the O is the part of the P, and I can just discard the O, because P should be detected. If the O has smaller area, I should discard that detection. So you can cheat a lot with pre-processing and post-processing, but my goal is to find how well can this object detection work out of the box. So next step, as I said, is usage of neural networks. And you probably have heard about PyTorch or TensorFlow. Those are the most famous ones. But as I said, we work in automotive industry, and I wanted to process as much frames as possible so I can average the values during these frames and make testing while actually I'm detecting. So I was looking for the fastest algorithm out there, and it looks like it was YOLO. I don't know, maybe something has changed. And we use YOLO 3, that's the newest one. Maybe there is YOLO 4, I don't know now. And that YOLO algorithm is written in Darknet. It's a different framework. It doesn't have any connection with TensorFlow or PyTorch. So I had to install it and test it. And the first difference comparing with hard feature classifiers, now you don't have positive and negatives. You have just a bunch of images on which you have your own object. And when you get these images, now there is this, again, tedious work. You have to go through all of these images and label where is your object. So input for your neural network will be these images, and you have to give it these rectangles. You have to give it where are the position of these rectangles. And there are these useful applications like Label IMG that lets you do this very simple and an easy way. You just make these rectangles, and it will automatically generate textual files which say where are the positions of your object. And as I said, I needed again another example because it would be boring to use it on the same. And I figured out, okay, I should make a beer can detection. And results looked like this. So I took 500 images of the beer cans with my mobile phone. And then I manually labeled all of these, and it took like 5 hours. So that's why usually people hate working with neural networks, because there is a lot of this tedious work, and then there is a lot of this work when you have to train, and probably your results won't be nice, so you have to change some parameters for your neural network, change some maybe change kernels, reduce the size of your image, and so on. And at this point I figured out, okay, this works quite nicely. You can see I've rotated now the beer can, it still can detect it. And it works quite nicely. And this is now done on the graphics card. This is GTX 1060, and I don't know, can you see, but to process one frame you need 0.06 seconds. So it works a lot faster than the previous algorithm. It works pretty nicely for what we need, but we have to now have the graphics card in our algorithm that we should use in vehicles. And as I said, because we are using this automotive industry, one part of the project is now to detect the vehicles, because our project had some connection with the vehicles that are in the traffic. So my next project was to detect the vehicles, basically, and almost everyone does that. So again, I had to change my project to make it more interesting. So I was looking for applications for 3D simulation for the autonomous driving. I've used several in a previous company, but all of those are proprietary. So I found one, it's called the Carla simulator. It's powered by Unreal Engine and it's sponsored by Intel. So it works like really nicely. You can use it as just playing around. You can drive a car. And the thing is, it also has Python API. So you can define almost anything. How many participants are in the traffic, how much vehicles are there, what are weather conditions. You can actually define how will your town look like. So this project looked like this. You can see 4 videos. Each video has different weather conditions. And you're probably thinking now, okay, I have to manually label like thousands of cars. But I cheated here. I downloaded the dataset for real cars. And the thing is, these cars, I think I downloaded from Stanford University. Labels were prepared for a MATLAB, and it was some kind of a binary file, so I have to read it somehow, and for that I could use SciPy. And once I got this to kind of readable state, I had to convert it to something that Darknet will understand, so I can use it in my own project. And at that point, when I prepared my dataset, trained the neural network, it worked fine. But the issue, I don't know, can you see, there is a red Coca-Cola truck and it couldn't detect it. So again, I had to make my dataset bigger. I needed images of that particular vehicle. So again, I used snapshot. Because it uses Python API, I can easily get this frame buffer, collect 500 images of that particular vehicle, and then again manually label it. And once I added this to the data set, train new neural network, and I tried to detect, at that point nothing worked. So that's the problem with neural networks. Most of it is trial and error. You don't know why doesn't it work now. But the problem was that at some point I figured it out. Like when you give this labeled image to the neural network, you have to label all the objects you want to detect. So I took images of vehicles and I labeled just that car I was interested in. But when the neural network is training, it finds all the other vehicles, but because there are no labels, it thinks, okay, there is no car. They've mistaken. So I'm actually training neural network not to find the cars. So there are these problems. You cannot find it on the internet. Mostly it's kind of, you have to dig a lot. And there is a lot of trying, try to figure it out. And when I fixed it, it was in a state like this. So basically these are the projects. I hope you find it interesting, and I didn't go much in depth with all of these projects, but I didn't touch anything except for Python with this, and build a lot of C and CUDA libraries and to actually run this neural network. So basically that would be it. You have any questions? Yes.
You say that you use OpenCV library. Is there some option for some GPU optimization for OpenCV library in Python?
Yeah, I think there is. I
Okay.
didn't use it, but mostly it's vectorized and it's parallelized.
Yes, it's parallel.
So you don't need, like,
Okay.
in most of case, like, image should be, I think, at least 4K. That makes sense.
Okay, because I know for C++, during the build process you can add some optimization flag for GPU or something like that. And second question is about the example with Arduino. Do you try to run such kind of software directly on Arduino? Because in this example you just use Arduino for control this LED display. Did you maybe try to run some kind of image processing directly on Arduino?
No. Arduino is just for displaying these
Okay.
letters. Nothing is on it. I think it's too weak for this.
Do you try maybe to move quickly this LED display?
Yeah, but it gets this frame anyway, so
frame.
it works. But on this camera, there will be motion blur, and if there is motion blur, it won't detect it.
Okay,
It's just
thank you.
completely different.
Thank you very much.
Thank you.
Hello, did you try to detect some complex objects with HAR classifiers, and did you configure the number of training stages, and what were the
No,
results?
basically, I just gave it the input and it trained. I think it was like 15 stages on whatever. At that point, I didn't have the need for that. After that, on my projects, I did. You could see like the face landmark detection. Yes, I changed a
And
lot
phase
of
detection was with HAR classifiers?
Yes.
Okay, thanks.
Hello, just a quick question. Did you try any other libraries besides OpenCV?
For image processing,
for
no, it's
pre-processing.
OpenCV. I've used for my own projects Pillow because I've done mostly my work in Python, but OpenCV looks like it's faster.
Thank you. That's
Okay, so thank you.